This week we're going to be continuing with our exponent rules, and we're going to look at rational exponents, and sometimes you're going to see these called fractional exponents. So if we have an exponent of 1/2, that means that you actually have a square root. So if we had 16 to the power of 1/2, that actually just means the square root of 16, which we know equals 4. An exponent of 1/3 means a cube root. So let's say I had 16 to the power of 1/3. That just equals the cube root of 16. If I had an exponent of 1/4, that means we have a 4th root. So I think you can see the pattern now. 4th root is 16. We know that that actually equals 2. So this just keeps going. You could have a 5th root, 6th root, 10th root, 100th root. Any fraction you can think of, you can use with this. Let's take a look at why this works. So we've looked at this before. We know that if we multiply something like square root 4 by that same exact square root, it just gives us what we had inside that square root, our radicand. So square root 4 times square root 4 equals 4. We want to try using rational exponents though. So let's try with rational exponents. So we have root 4 times root 4. We can write that as 4 to the power of 1/2 times 4 to the power of 1/2. 2 weeks ago, we talked about multiplying with exponents. We have the same base here. Our base is 4. When you multiply with the same base, you add the exponents. So this equals 4 to the power of 1/2 plus 1/2. If we simplify that exponent now, we have 4 to the power of 1, which just equals 4. So we just showed that this works. So we can generalize this. In general, our rule is that x to the power of 1 over n equals the nth root of x. So this is our general rule. And we read this as the nth root of x. In a more complicated case, we might have something like x to the power of m over n, and that just equals the nth root of x to the power of m. And that's an m in there, if you can't tell. So these are our 2 rules that we're going to be using today. So let's take a look at some examples and see if we can figure out how to use these rules. So for our first example here, looks like we're going to be using this rule here. We have the 5th root of x cubed. So we can use this rule going backwards. Right now, our problem is in this form. Instead of n, we have 5. Instead of m, we have 3, and our x is still the same. So to go from this right here back, we know we're still going to have an x. We know our m was the exponent inside the radical. So right here, that's our m. And our n is the degree of the radical, which is 5. So this equals x to the power of 3 over 5. So if you ever have an exponent and you're trying to write it in, or a radical and you're trying to write it in exponential form, you would just kind of work backwards using that rule. So another one like this, we have 6 is our n value. So we can say that 6 is the n, that 5 is the m. And we would write that as x to the power of 5 over 6. Remember, m over n. You also might get problems that are written the other way, where we have it's written in the exponential form, but we want to go back and write it in radical form. So what we would need to do here is figure out, okay, well, that 4 is my m, that 7 is my n. So we know it's the nth root, so 7th root of x to the power of m, and our m is 4. So 7th root of x to the power of 4. Another one, we might have x to the 2/5. Our 2 is our m, and the 5 is the n. So our 5 is our degree of the radical, and we're going to have x to the power of 2. So that's all you need to do to switch back and forth between these two forms. So let's take a look at how we can actually combine our exponent properties to solve more problems. So for this, what I want is we need to evaluate the left-hand side to find the value of a in the equation in simplest form. So what that means is you want to try to simplify this side of the equation, and then we'll figure out what a is. So to simplify this, we're going to use our exponent rules that we talked about a couple weeks ago. X to the power of 3/2 times x to the power of 2/3. This is going to be x to the power of 3/2 plus 2/3 equals x to the power of a. Before we can actually add these two exponents together, we need to get a common denominator. So our common denominator is going to be 6. So we're going to write that as x to the power of, to get 2/3 over 6, we multiply the denominator by 3. So the numerator gets multiplied by 3 also, so that's 9 over 6. Plus, in our second fraction, to get that over 6, we need to multiply denominator by 2. Multiply our numerator by 2, we get 4. Still equals x to the power of a. And now if I add these two together, I'm going to just continue that up here. I'm going to have x to the power of 9 plus 4 is 13 over 6 equals x to the power of a. And so I can say that 13 over 6 equals a. So I'm just getting that from right there. So this is my answer here. All right, so that was just plain old multiplying with exponents to solve this. Another thing you might see is you might have to divide with exponents to solve. So in this case, we are trying to simplify this. Remember that when we divide with exponents, we have x cubed, and we subtract minus 1/4 equals x to the power of a. So before I can subtract, I need to get a common denominator. This is already as a fraction. This is not a fraction, so I'm just going to make my common denominator 4. So to get 3 over 4, I'm just multiplying by 4, so 12 over 4 minus 1 over 4 equals x to the power of a. So we are going to have 12 minus 1 is 11 over 4 for our exponent. X to the power of 11 over 4 equals x to the power of a. So I'm setting those two equals, so 11 over 4 equals a. And that's my answer. There's one last type that we might see, which is this, where we have to multiply with our exponents. So if we're raising a power to a power, remember we have x to the power of 3/2, and we're going to multiply that by that 5 over 6. When you multiply with fractions, multiply the numerators and the denominators. So we have x to the power of 15 over 12 equals x to the power of a. So we know that 15 over 12 is going to equal a. We're not going to leave our answer like this though, because we can simplify that fraction. So those are both divisible by 3. So my answer is going to be 5 over 4 equals a.